Okay, good morning to all of you. Welcome to our Calculus 3, MAT163. We thank the Lord for this opportunity. I still waiting for my student. Nevertheless, we welcome you to our Calculus 3, MAT163. This is our week 8. We're now dealing with sequences. We already discussed sequence, and this midterm will be focusing on series. These are related. However, what makes the difference from sequence and series is the summation of the sequence will produce a series or perhaps an infinite series. There could be a possibility of infinite series, as we have seen an example here as pi. No? So we have pi as we know it is 3.14159265535, etc. And according to references that we already have computed through 2 trillion, more than 2 trillion of decimal places. So ganun na kadami yung accuracy. Hanggang ngayon, hindi siya terminating number. Still an irrational number. We consider pi as an irrational number because there is no termination on the decimal equivalent. In fact, computers are still calculating up to 2 trillion decimal places. So ganun 'yon. Meron libro ang laman lang ay yung decimal places ng no? Decimal places ng pi. Yun lang yung laman ng libro. O di ba? So anyway, meron nga nakakabisado na libo-libong places, no? Not so sure, but or hundreds perhaps. Kaya may contest na ganun, no? So anyway, so these are dahil lang po mga kapatid. I don't know what happened to my student. Hindi siya ayaw siya ano kayang infinity. Teka lang mga kapatid. Okay, walang indication yung estudyante ko kung online o ano. Anyway, our class is 9:30, so whether it's offline and online, I'll start on time. Yan, nagkaroon lang tayo ng konting paghihintay, nevertheless, no? So, ayan po. So, welcome those who are on their background view. Welcome to our Calculus 3. This is an actual class in LD Woosley, Bethany colleges for math majors. Salamat po. We welcome you. Ayan, baka maging monologue na lang uli ako dito. So, mahirap kaya mag-online class ng monologue. So, nevertheless, at least may kausap pang isa, okay na rin yun. So, yun yung nakikita natin dyan. No? So, ayan. So, hindi ako makapag-ano. So, anyway, dali lang mga kapatid. Sige, wait pa tayo ng konting minuto na lang. Okay, I will be starting now since these are recorded from YouTube live streaming. We're continuing that generally an infinite series is represented by this sigma notation, summation of a sub n when n is equal to 1 up to infinity. Whereas this is equivalent to an expression of sum from a sub 1 up to a sub n depending on the number. So definitely if this is an infinite term, so walang katapusan to mga kapatid. Actually, and so on pa to eh. So on to. So yung a sub n does not terminate the series, but it will continue as long as there is term. Ayan po. Teka. To make this formal presentation. Yan, and then plus up to, it follows, no? Wala nang katapusan to. Yan. So, ganyan ang infinite, okay? And then we have, we're adding terms, we are having cumulative sums. So, meron tayong mga cumulative sums, no? Up to some extent, no? And the end term, no? So, from here, no, we could define this as the sum, no? Kapag ang boundary niya ay nasa nth term, no, not infinity, kasi pag infinity walang ano to, no, this is generally an infinite series or simply series, no? But however, you could study a segment of this infinite series such that we will have a limit or perhaps an upper limit of the sequence that we are showing here right now. Anin ko lang yung infinite, no? Tingin ko may infinite eh. Hindi ko lang siya makita yung shortcut. Ano nga ba yung shortcut ng infinite? No, kasi I'm trying to learn shortcuts from MAT163. So na hindi ko dati ginagawa pero yan. Infinite. This, I think that's more accurate representation rather than alpha. Okay, so this could be segmented, no, depending on the problem. Perhaps we could have a portion, perhaps the first 5 terms or the first 10 terms, not necessarily the infinite term because we really cannot determine the infinite term. Acknowledging our 2 top chats from our YouTube channel, you could express your intention of sitting in on my Calculus 3 class. Okay, so huwag kayong mahiya at huwag mahiya magtanong, may right mid. Ayan po mga kapatid, no? So, yan. So, yan nakikita natin, yung infinite sequence. Sa aking estudyante ko, nangyari kaya student ko. Hindi ko na uulitin to. Ayaw kasi mag-ulit ng lesson eh. Kaya, from time to time, I'm making a record, no? A recording of our session. And the link I will just give to the classroom. So if we will start adding the terms, we get the cumulative sums, no? So if we will have a cumulative sum, assuming that we have a sequence here, for instance, the sum of counting numbers, okay? Salamat dun sa 1 at naging 2 top chat at naging 1 top chat na naman. So hindi yata ka interesado sa ating ano. So, okay lang yan. So 1 plus 2 plus 3 plus 4 plus 5 plus dot dot dot, and then we have plus n. Of course, this is the nth term, and then plus dot dot dot, meaning this is an infinite already, an infinite, no? So we could have an accumulation of sum starting from say the first sum. We could express this in terms of S sub n, no? Yung S sub n natin o yung sum. Yung sum natin, no? So we could express that okay into the sigma notation of this right? So we have the here per instance. So yan pa rin, following the pattern, that's the S sub n. depending on the nth value. Okay, the nth value. Of course, that would start from n is equal to 1. Then, ano nga ba yung infinite talaga? Nakalimutan ko talaga yung infinite. Sige, ano na lang natin. Ayaw. Enter pala. Walang nangyari. Ano ba yung ginawa ko dati? Magkasabay. Hindi ko na nagawa yung na kanina. Okay. Yan. So, assuming we have some number 1 here. O Dale, kumusta? I'm already starting my lecture, Dale.
Good morning po.
Oh, good morning. I'm already starting my lecture. We're on series right now, no? So, I hope you could submit this week your prelim exam, no? Plus the asynchronous task. So, we're now in infinite series, and this is the general formula wherein these will go to infinity. However, we could always determine the upper limit. Kaya nga, we could express this into this particular expression S sub n, meaning sum to a particular nth term. For instance, if we would like to say what? For this particular example, the sum of counting numbers from 1 plus 2 plus 3 plus 4, we may have this observation, no? Say for instance, the sum of the first term is obviously equal to 1. No? How about the sum of the second term? Or the two terms, the first two terms is 3. Tama ba, Dale? Nawala si Dale. Nawala ang ating estudyante. And then of course, next to this, the sum of the first 3 terms, 3 plus 3 is 6. Then sum of the first 4 terms is 6 plus 4 is 10, etc. No? So we could generate here the nth term such that the sum, speaking of the sum, okay, we could generate here 1 when you have 3, 6, 10, 15, 21, etc. So we could have that. However, we could have a general expression for this, no? We could have a general expression after the nth term, no? So yung nth term na yan, no, we could have categorization perhaps, no? So no, kasi nga pwede tayong magkaroon dito ng tinatawag na mathematical induction in mathematical induction in these terms, no? So yun yung makikita natin diyan, no? So we could always assume S sub 1. Now of course we have already S sub 1 here, and then we could assume that the nth term is correct. no? We could have an assumption that nth term is correct. And also there exists an sum S sub 1. Acknowledging Algie Gaming. Salamat Algie. If you're interested, I'm discussing here infinite series. Though this is a higher math, calculus 3 to, Algie. Hindi pang bata, ito'y pang kolehiyo. Ito ay tinitake ng mga math majors, ng third year math majors, no? Yung mga Bachelor of Secondary Education major in Mathematics. Salamat Algie, bigyan kita ng jacket. Salamat sa pag thumbs up mo Algie. Yan. Tapos na ba ang school mo? Online class mo Algie? Yan. So si Algie ay nag-celebrate ng kanyang birthday. Last week yun Algie, no? Yung celebration mo. So si Algie ay 12 years old, no? Na isang live streamer. So I hope na lumago ang YouTube channel mo Algie. Ayan, nandiyan naman ang mother mo. No? Nandiyan naman ang nanay mo Algie, si Teacher Ivy Clotario is there, no, to guide you as your mentor for your YouTube. Okay? So hindi talaga pumapalo yung ano. Ayan. So nagpapatuloy lang tayo sa pag-aaral. Okay. Walang pasok ngayong Tuesday. Good, good. Sige, relax ka lang dyan. May LS ka pa mamaya, Algie? May LS ka? Kung may time ako, puntahan kita. Ayan, okay, noted. No problem. Basta mga kaibigan natin sa YouTube ay ating ginadyakitan agad. Kahit yung mga ninja nila. Alright. So from here, we could have an assumption that there is an existing S sub 1. Yan. So, hintayin kong konti yung aking estudyante. Sayang naman yung tinuturo ko. Kung monolog ako. So, we have 2 top chat here from our YouTube channel. So, paramdam pa yung isa dyan. Bukod kay Algie na nakikinig dito. Ayan. So we could have an assumption here. Teka. So, I will plug in my mathematical editor here. So, yung ating sum, there's a sum of n plus 1. Okay, so viewing si, salamat Algie, no? So, we have here, again, our sigma notation such that you have an n plus 1. Assuming sum, yung sum na lang, no? Sum. So, by definition, yung sum of sum of the nth term is n plus 1. There exists a sum n plus 1. What will be its relation? What it will be its relation to the sum itself? Assuming based on this, no, this is just the summation of counting numbers, no? This is a summation of counting numbers. So the difference here is 1. So there is a difference of 1. So meaning if I would put this into an expression h sub n, so it must be 1. Now there is this an expression that will be added to 1, no, such that it will become n plus 1. So that's the summation n plus 1. Yan, nadali lang. Nasaan na ba yung estudyante ko? Ba si Algie ang matuto dito eh. So anyway, no, because as we increase hintayin ko lang saglit yung aking So kasi ito, magkakaroon to ng plus sum n plus 1. No? The sum plus n plus 1 rather. Okay, because yung series na to ay say, halimbawa, bigay tayo ng example, no? So yung S sub 1, as we have stated here, is equal to 1. So assuming that this is your n sub 1, yung magiging n, yung S niya, S sub 2, that's supposedly your yung S sub 2 mo, 1 plus 2 is 3 already. So yung dito, so if you will try to analyze, so the sum would be the plus the second term already, no? So the second term here, yun yung makikita natin doon. Ayan. So salamat Algie sa panonood, no? Okay lang, no problem, no? No problem. Thank you for dropping by, Algie. Ayan. Sige, isa-isahin natin to. We will just to have to analyze through mathematical induction. So sum of 3, so 1 plus 2 plus 3 is 6. Okay. And then etc. So it will flow. So we could have an infer, we could say here, now based on this assumption that S sub 1 plus the second term. Now the second term is A sub 2. A sub 2, ayan, is equal to S sub 2. Okay? So yan yung mga assumption natin, no? S sub 2. Kasi dinadagdag mo lang yung second term dun sa first sum. Okay? Dinadagdag mo lang yung first term dun sa yung second term dinagdag mo dun sa sum number 1. So naging S2 siya. In like manner, so I'm developing a pattern here, no? In like manner, the sum of the first two terms when the third term was added, no, that would result to the sum of the three terms. Okay, and so on. This will go this will go kaya ito hindi ito. So yung generalization natin, no? So this is A underscore n plus 1. Yan. Okay? So here, if we will again S sub 3 plus A sub 4 equals to S sub 4. Yan. Right? So from here, we could have a generalization. No? We could have a generalization, and perhaps we could have some. We may reflect. We may reflect the sum into simpler form when dealing with the nth term. When we are dealing with nth term, we could always reflect, no? So yun yung makikita natin doon. Yan, so saglit na mga kapatid. Hinihintay ko talaga yung estudyante ko, sayang. Sayang. Thank you, Algie, for dropping by. Really appreciate your presence. Yan. Na-offline yung kasi my student is from Isabela, so there might be some connection issues. May mga connection issues tayo. Ito pala, isa plus. Isa plus. Okay, I'll just wait for a few minutes before we continue. Tagal ng student ko ah. Yan. So siguro tutuloy lang tayo. So and so on to, no? And so on. That's why we have a general, the sum of the n plus 1 term is equal to the sum n plus the n plus 1 term. So yun yung makikita natin dyan na description nito, no? Yan, salamat sa mga mga icons mo, ano, no? Ayan, so yun yung makikita natin dyan, no? So of course we could generalize this for a while, guys. I need really to have a break while waiting for my student, then I'll come back. Saglit lang, guys, promise. Okay, my students not yet here. Sige, let's continue. Let's continue. Okay. So here we could continue on this sequence, no? So magpapatuloy tayo, no? Even my students not, it's really a hard time connecting, no? So anyway, this is a recorded view, no? So we could see here that the sum in the nth term by mathematical induction, though I will not show it anymore, no? Because it will be discussed in uh, in algebra and some other lower mathematics, that the sum of the nth term by mathematical induction, if we will follow the logical structure here, would be, we'll get the n plus 1 over 2. So that's the sum that we will have here, and this will become very large as the end value increases, no? As the end value increases, it will be very large, so meaning there is no limit. This is an infinite series, I would say, no, in terms of its sum. Since the sequence is infinite, it follows that the series is also infinite, no? Yun po yung makikita natin dyan. Alright, so ayan. So I'm hoping my student could still catch up. Okay, as we continue, we have another sequence here. For example, so sige. So ito, subject to ano lang to, verification ha guys. Pwede nyo i-verify yan yung sum. You could always verify that. Hindi ko alam bakit di makakonect si Dale, yung estudyante ko. Buti pa si Algie nakakonect. Salamat Algie kanina ha. Salamat sa pag ano mo. So pwede itong you could research on this, but this had been proven through mathematical induction, no? Assuming example sum of 1 plus 2 plus 3 plus up to uh, yan 98 plus 99 plus 100. So we could always make use of this formula, no? So by following this by mathematical induction, that we assume that the first term is correct, no? If that is correct, it will follow through also through this, no? It will have ayun, yung kasi mathematical induction, you assume that your first term is correct, no? So before that, no, so we could say that S sub 1 is equal to 1. So 1 plus so we have said that already, and then we have S sub n. We have S sub n is true to all of the terms, no? So pwede natin siyang i-test for n plus kumbaga yung pwede nating i-test siya kapag dinagdagan natin ng n plus 1 term. So yun yung makikita natin dyan, no? Pag dinagdagan natin ng n plus 1. Yeah. So n plus 1 term. So for here, we could plug in the definition. So we could plug in here the definition. Okay, plus n plus 1. From here, we could pwede natin siyang gawing one fraction. So we could say that this is multiplied by 2n plus 2. Okay, so yan yung magiging natin dyan, no? So that there could be an inclusion, and then from here you could just simplify the numerator. Okay, you could simplify the numerator. Paano nga ba masimplify ito? So of course, you could plug in some your mathematical concepts here. N squared plus n. Ayan, tanggalin na natin yung parenthesis. Okay, so from there, what you could have is a trinomial, a simplification of trinomial square. Okay, a simplification of a trinomial square. Okay, so what will be? This will become 3n. Tanggal na to. And of course, this is factorable, obviously. Yes. So this is factorable. So by factoring, we could have the result. Okay, so what will be the factors here, guys? If you're listening, Algie is still there. So this will become, obviously, the factor here would be n plus 1 times n plus 2. Okay, so which is in fact the next phrase, no? So ito rin yan. Kapag sinip natin yung shifting from n plus 1 to n plus 2, so babalik tayo doon sa definition, mga kapatid. No, if I would like to shift, ito yung beauty ng mathematical induction. This is an indirect proof actually, no? But there are many references where we could prove this. This is not beyond the scope of our, since this should be done in lower mathematics, no? So if we would like to shift back from n plus 1 to ano na nga ba yun? Right. Yan, if we would like to shift back to just n, so ano mangyari yan? So of course, we will be rewriting the equation. Of course, constants may not be affected by this, no, because they are constant. I'm just showing this for this case, no, pero sa susunod hindi na. No, parang ano lang yan, para maunawaan natin yung proseso. So sinip natin from n plus 1 to n. So ito, magiging n na lang to. Tama? And then, yung n mababawasan ng isa. So, n plus 2. Same definition that we have. Okay, same definition. So, bumalik tayo dun sa original expression niya as we shift. Hindi pala, teka wait. No? Okay. Okay, so I will be reading the mathematical induction to you. No? Now, let's go back here. No? Looking for the sum of the first 100 counting numbers, so it will be simply expressed into this sum, as we have already solved using mathematical induction, that the sum of these counting numbers could be expressed in terms of n times n plus 1. So you don't need to compute 1 to 100 literally, because by infinite series concept we could do that, no? So we could just substitute here. So nangyari. So we have here n, the number items 100. 100 plus 1 is 101, and then divided by 2. So this would mean 1010 over 2, which is equal to what? Sorry, right, my mistake. Okay, this is supposedly 1,000 10,100, no? Tama, 10,100. Kulang ako ng zero, guys. Pasensya na. 10,100. So, of course, so we could divide this by 2. That becomes 5,050. Okay, so that's the sum of the first counting numbers. Okay, I think I have some problem on my internet. Wait for a while, mga kapatid. Divided by 2. So, this. Okay, so my video is not no. So, anyway. So, tuloy lang tayo. No, yung audio ko may problema siguro, yung video. Okay, let's continue with another sequence. This time is another series that we will look into as a matter of example. Okay, a matter of example. Wala na yung estudyante ko, hindi na nag-ano. So we have here a sequence or a series. Now, pag kinuha mo kasi ang sum series na siya, guys, yun lang pagkakaiba niyan. So we have 1/2 plus 1/4 plus 1/8 plus 1/16, etc. So of course, by definition, this is 1/2/n. So, yan. So of course, it will continue to follow. So that's our sequence. Yan. So medyo yung aking sa Google Meet, di rin naman. Medyo may problematic talaga yung network. Alright. So nevertheless, we will continue. So I think ongoing naman ako dito sa YouTube. So as we examine this, so by definition, we could always we get here the sum. We get here the sum of each, no? We have a partial sum. So we could always get that, no? So we could always list the sum 1, sum 2, no? So tingnan natin. Sum 1 is of course 1/2. Then we have sum 2. So 1/2 plus 1/4. What's the answer? So 3/4. Then we have here S3. Sige, compute natin yung S3. S3 is equal to 1/2 plus 1/4 plus 1/8. That would become, Algie, can you hear? Can you get the sum of 1/2 plus 1/4 plus 1/2 plus 1/4 plus 1/8? Algie, if you're listening, acknowledging 2 top chats from our YouTube channel. Ayan po. So, may problematic talaga tong ating network. No? Not so sure, no? If, ayan, okay na pa naman so far. Ayan. So, salamat doon sa 2 top chats natin. Okay, so let's continue here. No? So, for S3, so we have 7, 8. 7, 8. And then S4, pansinin nyo guys, yung sum niya, pansinin nyo. Yung S4, S4 is equal to, tantananan, 15/16. Pansinin nyo. Until it reach, no? So nevertheless, so what would be our observation? Our observation here is that it is approaching a particular limit. There's the sum, we could have a particular limit. No? No, meaning it will approach, no? Kasi kung tutuloy pa natin to, yung sum number 5, yung S5 natin is equal to 15/16 plus 1/32, that is 31/32. So pansinin natin, no? Anong limit niya? The sum approaching 1. Okay, so we have here a friend here acknowledging ninja ni Mr. Mier. Salamat sa iyo. Salamat sa iyo, Mr. Mier TV, sa pagbisita. Salamat sa thumbs up mo. Yan. Thank you for dropping by. We are online now. Though my student have a problem in reconnecting, I'm continuing on my lecture. So, since this is a stream, it will be recorded. No? Bibigay ko na lang sa kanya recording. Okay, but I'm opening this also for YouTube for people to come and perhaps learn. No? So, this time I'm a math professor. Sometimes I'm a devotional leader. Sometimes as Sunday school teacher. So yan po yung, kasi ang category ng ating live stream ay education. So we are educating our young people. Thank you Ninja, no? Mr. Mir. Yun, hinihintay ko pa rin yung estudyante ko. Okay, pansinin nyo. Obviously, it will approach 1, mga kapatid. So the limit of the sum approach 1. So there is this pag tinuloy-tuloy pa natin S6, it becomes 63/64. No? S7, it's 127/128. So it almost 1 but not equal to 1, and it's approaching 1, and it will never be equal to 1. So yan ang tinatawag natin na there is a limit, mga kapatid. Kung may limit, no? If there's a limit, there exists a real number that has a limit. Therefore, we could say from this example that there's a limit, no, for the sum. If I will define again the sum here, not definition of sum, S sub n would be equal to sigma, would be equal to, no, I'll be using some mathematical here, no? I equal to 1, that's the first term, and then we have here up to n. Ayan. So I summation of A sub I when I is equal to 1 up to n. So this could be further expressed in terms of its series A sub 1 plus A sub 2 plus A sub 3, etc. plus A sub n plus. So you have infinite series. And if there exists a limit such that there's a limit, now there's a limit to this sum, and I will put it in definition. So there is a limit, kung mayroong limitasyon, no? So kasi na-observe natin dito sa sum na to, may limit siya. Hindi siya pumapalo ng 1. It's almost less than 1. As you observe on this sum of this series, per sum 1/2, 3/4, 7/8, 5, 15/16, 31/32, so is almost less than 1. So we could see here, acknowledging Ma'am Trixie Vlog. Salamat sa pagpunta, Ma'am Trixie. Dahil dyan, bibigyan kita ng madam ng jacket. Salamat. Kayo ng ninja ni Mr. Mir. Salamat po. So I will put some jacket on you. Thank you. Welcome to my calculus class. I'm now discussing infinite sequence and series, no, as part of calculus 3. No? At tapos na kami ng integral differential. This is a preparation for power series as well as multiple integrations. Ayan po. Thank you, madam. Dahil dyan, bigyan kita ng jacket. Ayan, kayo ni Ninja. Si Trixie 051. Madam, ano pang oras ang inyong live stream, madam? Madam Trix. Para mai-promote din natin. Ayan, so thank you. Yeah, at least yung may mga pa-BG-BG dyan, malalaman yung yung ating this is a recorded session, so babato ko rin siya sa Facebook live stream mamaya-maya. Okay, kasi ang problema ko yung estudyante ko hindi makakonek. Kaya ngayon sa online, nagmo-monologue yung professor. Monologue po tayo ngayon, mga kapatid, no? So ayan po. So from here, we could say that there is a limit of this sum by definition, and if this limit as it approaches infinity has a limit. Now there's a limit, meaning there's a limit, say a value, no? So for this case equal to 1, a numerical value. Ay, mali ako. Ano ba yung tinype ko? As n approaches infinity. Ayaw niya. Ay, right arrow. Yan. Ayan. So there exists, say, limit L. So if there exists, no, just like this example that we have, no, seemingly there exists a limit that is less than 1 or approaching 1, exists a real number, not just an infinity. Okay, then we could say that the series, so therefore, so lagyan natin to, if limit a real number exists, therefore ano nga ba yun? Therefore ba? Tama ba? Ayun, tama. So therefore the series is convergent. So, convergent series siya guys kapag meron siyang existing limit. Ganon din sa sequence. Convergent din kapag yung pattern niya nag-a-approach siya sa real number in sequence. So, in sequence, no? Pag kinuha mo yung sum, nag-a-approach din siya into a real number. So, therefore, it's convergent. Okay? Otherwise, no? Otherwise, so anong tawag sa kanya? Otherwise, meaning there is no real number exists as far as the limit is concerned. Otherwise, the series is divergent. Divergent. Ayan po yan mga kapatid. Okay, the number is called sum of the series. If the sequence is divergent, then the series is divergent as well. So may relation yung kung anong nature ng sequence, yun din ang nature ng series. Right? So yun yung may kita natin diyan. So if the sequence is convergent, exists a real number in its limit, then the series is convergent as well. Yun, nagano. Dali lang mga kapatid at ako'y magcha-charge muna. Kaya pala mahina yung taloy nitong ano ko. Alright, so let's move on. So that's the definition of a divergent and a convergent series. So pag may limit siya, ito ay convergent. Kapag wala naman, divergent. So yun pong makikita natin dyan. Okay? So those are definitions. Okay, there's an example here, another example. Suppose we define a series, no? As we go back again, we define a series. We define a series by the definition, and there's a given definition here. Okay, there's a given definition. A sub n, so there's exists an n, a partial sum. Okay, given here the definition, no, 2n over 3n plus 5. Okay, so the question is, ano nga bang tanong dito? Find the limit of the sequence. So there's a limit in the sequence. Okay, so we could always manipulate this. No? So kung yun yung sum definition, so we could focus on the given sum 2n all over 3n plus 5, and we could get the limit of that. So supposing we are getting the limit as n approaches infinity. So that's the assumption that we have here. And okay, the limit at n equal approaching infinity. By the way, approaching is not equivalent to equal. No? It means it will just limit its limitation, but it will never touch at that particular real value. Yun yung tatandaan natin doon, guys. So, assuming that we have here 2n, 3n plus 5. Yan. So, yan yung ating. So, we could manipulate this, guys, by dividing both sides of the equation so that it will all have a division by n. What's the purpose? Because since n is approaching infinity, division by n would mean equal to 0. Tandaan natin yan. It will be equal to 0. So, ayan. Kung i-divide natin to, guys, sa 1 over n on both numerator and denominator. Tingnan ko kung gagana to. Ako, hindi yata gumana. Yun, gumana. Mali ako. Mali. Yan, okay, good. So, dividing both sides, numerator by 1 over n. So, what we gonna here, cancel yung 2n over n. That becomes 2 only. And for the denominator, that is 3 plus 5 over n. So yun yung makikita natin. So, ito ay wala na. And then, 5 over n. Okay, 5 over n siya. So, here, of course, the constants will be, it won't matter for the limit. No, it won't matter anymore for that limit. No? So, kasi constant naman siya, walang problema doon, guys. So, pag kinuha mo yung limit noon, constant, walang limit kasi nga constant eh. Nagkakaroon na ng limit pag variable. No? So, of course, from here, so pwede natin sabihin, so ang magka-cancel lang dyan, 0. Yung 0, 5 over 2 and 0 yon. So, what remains is 2/3. So, the limit is 2/3. No? So, yan yung isa nating example. Okay? And then, we also have some geometric series as an example. No? So, most of these are what we call arithmetic series. No? They are arithmetic series. But there is also what we call geometric series. Because they're, instead of looking into common difference for each of the terms, now for instance, 1, 2, 3, 4, 5 up to 100, so the common difference is equal to 1. But for geometric series, it will be common ratio. For instance, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 10, 1024. So, ganun siya. Alright? So, ganun yung ano natin. No? So, yun naman ay tinatawag na geometric series. So, let's have another example for that. As a matter of introduction, by the way, tuloy lang natin guys mamaya, no? So, I'll be breaking by, say, 11:15 and then I'll be coming back by 1 o'clock. Okay? So, tutuloy lang natin to. Kasi two sessions kami and then next week naman, modern geometry naman yung dalawa. Para sabi ko sa estudyante kay Dale, ay isang pisa na lang. Okay? Isang pisa na lang siya. Okay? So, ayan mga kapatid. No? So, ayan. So, yung mga, sige, noted dyan. So, okay, let's manipulate this. An example of, example again, example 2, or sige, another example na lang, is an arithmetic or a geometric series. No? Example, geometric series. Geometric series, no? So, ayan. So, S sub n. So, in the form of a common, kaya hindi nababago yung constant mo. Ang constant diyan yung ratio, hindi yung difference, guys. So, it will rely on the ratio. No, because it is a geometric series, no? So, yan yung tatandaan natin. A plus A times R. Right? Ay, hindi. Ano nga ba yung bilog na yun? Nakalimutan ko. A dot siguro. A dot R. Ay, hindi rin. Okay, wag na nga lang. Ba't ko ba pinoproblema yun? Ayan, AR plus times AR squared plus AR cube, no? So, yan yung pattern natin, guys, no? Until it reach the A raised to n minus 1. Bakit n minus 1? But n minus 1 kasi yung first term mo walang R. Kaya minus 1 lang. Tama? Kasi R raised to 0 yun eh. Pag R raised to 0, if R is not equal to 0 when raised to 0, that's equal to 1. Kaya mga kapatid, no? Ayan, from this geometric series, we could have a manipulation on this. No? We could manipulate that. Right? Such that our manipulation here would multiply both sides of the equation by R such that, sige. Sub n is equal to AR. So, naging AR na siya ngayon kasi multiplying both sides of the equation by R. So, AR squared. Okay? Plus AR cube. Alright? Plus dot dot dot. Ano susunod? Since multiply mo kay R, naging buo na siya. Plus AR raised to n. Alright, so that would happen. And then from here, we could subtract it from its original. Now, subtracting, yan, S sub n with the one that is being multiplied by R. Yan, so yan yung ating makikita niyan. So, from here, we could say that yung S sub n, so, tingnan nyo maigi guys yung pagkakaiba, no? Yung S sub n minus R, S sub n. Okay? So, of course, from here, we could have some cancellation. Anong matitira dyan? So, yung AR cancel, yung AR squared cancel, yung AR cube cancel, at yung AR raised to n minus 1 cancel kasi hanggang A raised to n ka eh. So, ang matitira lang dyan ay yung dalawang term which is, but this is more of a subtraction, no? So, A plus, or minus rather, A raised to, A times R raised to n. So, yan lang yung natira dyan. Then, from there, we could manipulate such that we could solve for of course, factoring R or S sub n here, if you will factor it, so yung S multiplied by 1 minus R multiplied by 1 minus R, yan, yan, is equal to A, factor out mo rin yung A, 1 minus R raised to n. Yon. So, of course, this is R, sorry. Acknowledging for yes channel. Salamat sa pag-thumbs up sa team ni Ma'am Tritol. Salamat po. Salamat Sir Tritol at sa iyong at kay for yes channel. Thank you. Welcome to my Calculus 3 class. So I'm reviewing this sequence and series, and we are actually deriving the geometric series. Geometric series, guys. So ayan po, dividing both sides by 1 over R, then you will have the answer for S over N is equal to A times 1 minus R raised to N all over 1 minus R. Okay? So, yan po. So, that is the formula for the sum of a geometric series. Yan, geometric. Yung sum nila. Okay? So, yan. Magandang ano rin yan. No, kasi, meron din tinatawag na convergent. No? Pag convergent, meron siyang limit. No? Meron din kasing mga, lalo na magiging convergent siya kapag siya ay okay, so meron siyang tinatawag na as it approach infinity, so there is an existing limit. No? So paano natin makikita yan? Kapag ayan, makikita natin yung baba niya, no? Kung bababa siya. So there's an existing limit. No? And the parameter here, no, if your common ratio is between -1 ay, ano nga ba yun? Nakalimutan ko. Hindi na nga lang, wag na nga lang. Anyway, meron naman dito eh. So your R is on this particular scenario, hindi na nakabalik yung estudyante ko. That's my problem. No? Okay, this is equal to 1, then we know that R raised to N is equal to 0 because it's fractional. No, fractional. As it approaches infinity, so we could say that R raised to N approaches 0. Why? Because it's fractional. Kung ang ratio mo ay fractional at habang nag-i-increase yung hanggang infinity, magsi-zero siya. Alright, magsi-zero siya. So yun yung makikita natin diyan, no? So it will have a 0. So fractional, whether positive or negative fraction pa yan, basta fractional, no? So it will, except 1 kasi pag 1 ay hindi, no? So it's always less than or equal or less than 1 or -1, whichever is the case. So this would have an approach equal to 1, equal to 0 as R approaches, right arrow approaches infinity. Yan po. Yan po ang condition na yan. And that would be the case, we could always compute this if that would be the case, no? So kung yung R raised to N is 0, so that becomes A na lang. A, and then R approaches infinity as R approaches infinity. So ang mangyayari dyan, no, we could always simplify this. Pero tuloy-tuloy ko na rin siguro to. Kasi kung stop pa, sayang din yung broadcast. No? Anyway, sige, tuloy-tuloy na lang. Tingnan ko hanggat di pa ako gutom. Alright. But sana makakonect na yung estudyante. Tingnan ko nga, teka. Hindi siya makakonect eh. Anyway, sige, yung mga pa-BG-BG dyan, kayo na lang manood. Right? So, yan mga kapatid. No? So from here, this could be reduced, no? If the geometric series is such that it's a fractional ratio or it will have a convergent geometric series, mga kapatid. Such that this will become equal to 1. So, tanggal na tong A na lang matitira. Yan na lang matitira, guys. So, that would become a convergent. No? It's convergent, mga kapatid. This is a convergent series. So, otherwise, it's divergent. Of course, because there's a limit. No, may limit yung sum. No? So, there's a limitation of the sum. Okay, so it's another example here. Example. For example lang tayo. So find the geometric series. Find the sum of the geometric series whose sum is equal to this expression. So we have 5 minus 10 thirds plus 20 over 9 minus. So there's alteration here, no? So okay, plus etc. Okay. So from here, now we could analyze the first term is equal to 5. Okay? In solving, find the sum, no? Example, find the sum. Yan, find the sum of the geometric series. Okay? So from here we could analyze. There are two things that we need to know. First is what is A. A is obviously the first term equal to 5. So the first term is equal to 5. And then the common ratio R. The common ratio R. So yan dapat ang malaman nyo. So paano yung malalaman yan? Divide mo yung second term by ano. So how will you know your R? Basically, now if you may recall your algebra, your ratio, supposedly your second term over your first term. So yan. So from there, we could always say that 10 thirds over 5. Negative 10 thirds over 5. So from here, so obviously the answer is negative 2 thirds. So the common ratio is negative 2 thirds. Then we have already an expression here. Then since the ratio is a fractional ratio, meaning less than negative 1 or 1, whichever perspective, so that would be the case. We'll be using this convergent formula for getting the sum of the geometric series. Ayan po mga kapatid, no? So, ayan. So, titingnan natin dito. So, from there, we could just substitute. Now, we could just substitute the sum. Okay. Which is the first term, it's 5 over 1 minus R. So, 1 minus, mali ako doon. 5 over the quantity 1 minus negative 2 thirds. Yan. So from there, we could have a simplified term. Of course, we could manipulate this expression. Okay, so we have here 5 over, so the remaining expression is 5 over 5 thirds. So because 1 minus negative 2/3 is 5/3. So 5 over 5/3 will obviously cancel 5 and you go, the 3 would go up, so that is equal to 3. So the sum is equal to 3. Okay? So marami pang mga example dito sa book. I already have sent this. There are. No? Perhaps another example is an application for repeated fraction or repeated decimal. No? So okay din tong example na to. Titingnan natin. For another example here. So we have here the given oo nga no, hindi ko naisip yun 3.17. No, yung paano kaya i-underline to? Overline pala. Bale, sige. Pag-isipan ko yan. So this is 3.17. Ano nga ba yun? Hindi ko naisip yun Sa accent ba yun? Sayang, may shortcut nun. Mali. Overline. Nakalimutan ko lang to Meron siya Okay. So anyway, assuming that this is a repeated decimal, no? So yung ating expression dyan ay 2.317, 17, etc. So that question is, how will you express this into its fractional equivalent, the improper form of this, no? So we could make use of this geometric sequence. Paano magiging geometric sequence yan, sir? That is based on the power of 10. Remember that. So there's a power of 10. So there is every 17 has 2 decimal place occupied, starting on the third or the thousandths place or the hundredths place, I would say, no? So tens, hundreds. Tama, hundreds place. So that equivalent to 10 cube, and then 10 to the fifth and 10 to the 7. So kung express mo yan, so this is 2.3, that's the fixed first term, over 17 over 10 cube. No? 10 cube. Ayan. Plus 17, increment of 2, kasi that 2 repeating places to, 3. Ayan, plus. So, etc. No? So, siguro I could write again this one. 5 pala to, sorry. Okay, so etc. guys, no? So yan yung okay, so yan etc. So from there we could say that your first term of course is 2.3. Then your first term as the series, because 2.3 is not part of the geometric series. So they're not part of the geometric series, no? However, that could be part also of the particular answer, no, that we are computing right now, no? So all right, so from here we could say that, so 2.3 plus, which is the first term is 17 over 10 cube. That's the first term. However, lobat ako. Okay? So 17 over 10. Of course, may shortcut dito sa algebra, no? Pero pinapakita natin yung derivation. Paano nangyari yan? So yan po, pinapaliwanag natin mga kapatid. So all over 1 minus, so because the common ratio is 10 squared, no? If you will notice, 10 cube, 10 to the fifth, no? Ito 10 to the fifth to, sensya na. And then 10 to the 7th. So ang increment of 2, 10 squared. So kasi 2 digits siya, no? So etc. No? So from here, so we could say that this is all over 10 squared, 1 over yan. 10 squared, no? So ayan, so bahala kayo na mag-solve guys, simplify, no? So I will just tell the answer. The answer is 1,147 all over 495. Alright? So yan po mga kapatid, ang makikita natin dito. Okay, meron din tayong tinatawag na aside from the arithmetic series that we are already discussed, plus the geometric series, we also have a harmonic series. When we say harmonic series, if you get the reciprocal of the terms, it will follow an arithmetic series, mga kapatid. Yun po yan. Or simply series. It will follow a series. For instance, for this case, no, another example that we may have, okay, so example here, harmonic series. Pag sinabing harmonic series, pag kinuha mo yung reciprocal nun, magiging arithmetic sequence siya or series. Yan ang ibig sabihin ng harmonic series. Alright? So if we have here the summation of 1 over n. So that's the sigma of 1 over n. Sorry. Okay. As pala muna dito. As n approaching or equal to 1, up to infinity. Yan. So up to infinity. So we could express this into its equivalent series, no? Such that starting from 1, 1 over 1 is 1. No need to write in fraction. 1 over 2, 1 over 3, 1 over 4, no? Etc. Okay. So that is a harmonic series, meaning when you you express the reciprocal, it will follow an arithmetic or simply a series. Kaya lang harmonic siya, reciprocal. Ayan. So ayan po. So these are I will leave the proving to you. Show that this is a divergent series, meaning there is no limit. Walang real number limit to. Okay, so I'll just leave the proving to you. Okay, so mayroon tayong mga test of divergence, no? So if the limit does not exist or the limit is not equal to 0 as it approach infinity, then there is a series we call divergent. It does not exist, no? If the limit does not exist or if the limit is not equal to 0 as n approaches infinity, then the series is divergent. Okay? So there's this what we call a limit test na may kita natin. Alright. Okay, so I will just leave this as an take home. No? So there are divergence here. Iniisip ko yung 0 not equal to 0. Sige, may mga test question siguro tayo dito. Siguro exercises na tayo. Alright. So, I will cut this short and then by 1 p.m. I'll be coming back. Okay? So, sige guys. Sige, I'll be coming back by 1 p.m. So, test questions na tayo. Okay, so I'll be seeing you by 1 o'clock. Okay? So, yan. Salamat sa lahat ng mga bumisita sa ating sa ating broadcast ngayon for our Calculus 3. Okay? I'll be discussing some exercises afterwards. Okay? So thank you, and Dale, catch up. Okay? See you and God bless.